there.
This is kind of a minor one.
Yeah.
I just have a word that says unused variable because you put empty char in the name of the char. Is that required to the current process?
Yeah, right. So it said there was a certain variable that was not used?
Yeah, that would be char when you store the details.
Right.
Is that fine to leave it like that? Or?
So the warning is occurring in the code that was provided to you, right?
Yeah.
It is okay to yeah, so yeah, I know about this thing. There's a bit of it's really interesting. I'm sitting, on this perch, and I get all these emails from different students about error messages that they're encountering and so on. And it's I must say it's quite interesting to me because I learned pretty quickly about the diversity of different systems, different compilers, and different environments in which people are running this thing. And suffice it to say that people out there in the class are, using compiling this thing with a variety of different systems and running it on different systems, and they yield different results, right? Different warning messages. So that is one that does appear. I think I saw that on TuxWorld when I was doing that. Yeah, exactly. So I think that's a pretty standard one. This one with the conflict in symbols for debugging seems to have been cleared up now. They cleared that one up, but that bit people for a bit. There are one person who reported an issue where it was reporting a possible uninitialized variable. Have any of you seen that? No? Okay. It was question 1 on that, which was interesting. I think it was a mistake in his code, though. But he thought it was in the code we had provided. And there are cases where a system, if you have assertions turned off and you have an assert false, it may think that you just pass through here just fine. And so if there's a path, let's suppose you have an if, and one side goes to assert false, and this should, this would often yield the program to crash. Another side, assigns to some variable. Maybe this variable is here uninitialized. It's not initialized. Here it assigns to some value. Here there's an assert false, and then down here you have some use of a, b equals a plus 1. In this case, it is possible if assertions are not turned on that it could think, boom, it can get through here. And in general, it's a good practice to initialize this thing to make sure it is initialized. But some people are reporting that. Okay, questions? Yeah.
In the case of maxLM, that constant that's not defined with
Right. Correct.
I decided to define it in vector.h, and I run into an error where if I want to avoid giving warnings of comparisons unsigned and signed integers,
Right.
I have to duplicate them. I have to basically just create specifically named integers just for certain comparisons.
Is that because maxLMs is so large that it's...
Well, I started using it in bits for my code because it's convenient, but the issue is that if I use it in my code, it has to be unsigned. If I use it in the code that we're given, it has to be signed. So I either get 2 errors
I
from
see.
it or 1 error from the code given.
I see. You're saying your code requires it unsigned just for hygiene. You're sort of saying, okay.
Also because if I don't, then I get a bunch of errors because you can't compare signed and unsigned. For instance, when you're counting I'm not sure.
If sorry, if casting it?
Cast it.
Yeah, you could probably cast it. That would have been my first.
The issue is that in the vector structure, the size is unsigned. So whenever you like variable, you're supposed to put unsigned.
I see. So when you're saying duplicate code, you mean sort of one version of maxLMs that's signed, one that's unsigned?
Exactly.
Yeah, that's okay. So are you pound defining it, or are you doing this a constant?
Constant unsigned.
Yeah. Yes, because the code that has been passed to you does require it sometimes as a signed bit, right?
Yeah.
And your code, Precisely. So document it, and that's fine. Yeah, that's fine. I'm surprised. I would think casting it would allow you to deal with that, but dividing it twice and just being clear about you can put them next to each other, right? So if you change one, the other is right there, because you want to make sure that you change them together. Could one of those be defined as the cast of the other? Do you only have to change it one place? I think so. I think you could define a const.
I don't know how to do that kind of test and see if it really caught that.
Last time around, bracket, bracket.
So if you wanna do bracket, oh no, you could do it with the parens unsigned int, right? Or are you using u underbar int? There's actually a built-in type also, and I forget. Is it int underbar u or u underbar int? There's also another way to put it that way, but unsigned int, you can just write it just like this and put it in parentheses. So if you add that, it would cast this to an unsigned, this otherwise signed value to an unsigned. Okay, so you can put it in those parentheses. Okay, so that's a good question. Other questions?
In general, when you're organizing unit tests,
Yeah.
what happens when you get into a structure where you have functions that call each other?
Right.
And what order you do the test?
Mutually recursively?
Yeah.
Yeah.
I looked it up for Java and JUnit testing.
Right.
And I know that in JUnit testing, it's very much recommended that your tests run in random order.
Right.
You don't get into specifying which order they have to run.
Yeah.
And so what happens when you get into having to establish that one test works before another?
So you're saying if you have I'm piecing your question into, parsing it in two different ways. One thing is you have a mutually recursive thing, like foo calls bar and bar calls foo. How do you test that?
Yeah.
So you could do successive stubbing out of these, or mocking would be the equivalent in object-oriented. So you have a fake bar, and foo calls the fake bar, and just you verify that when bar returns sort of an appropriate thing, foo works, and then fake foo, and then you test them as sort of an integration test. You test them together, because really conceptually these are kind of a unit, and to really do a thorough test, you need to test them together. But there could be some bugs of foo that are exposed just even when you return a most simple value from bar, it leads to some obvious sort of problem in foo, and so that's often worth doing. As far as the ordering of tests and sort of randomization of tests, that's kind of more 370 or 371 material, but when you have these sort of mutually recursive structures, I don't see a problem for randomizing just sort of that stub structure I was talking about. Those two cases, either one could be done before the other. What's really important is there's some test that sort of tests this as a unit and maybe deals with external calls from this through a stubbing. So this is a meaningful unit of functionality. Yeah. I don't know if that addresses your question some. Okay. Other questions though? These are good questions. So who would like to hear me talk about a certain topic related to the course, of course? Is there a whole topic that people would like greater discussion about, or reminders, or where they'd like to hear me talk about what I see as the important points? Sorry? Right, precisely. That's what you find related. So what topics would people like to hear that I think are sort of major takeaway points? Sorry?
I'll interpret something.
Yes, yes. Yeah, what topic?
Answer the question.
Okay, so what, for what topic, yes, subversion, okay, good. So, with subversion, there are, I'd say, on the order of 4 or 5 big take-home messages that I might walk away with, in which I might very readily test on an exam. What am I not going to test on subversion? There's certain things I consider sort of too trifling to test about. So, for example, the ordering of arguments to SDN update or SDN checkout. I just don't. Those things are really easy to do a man on it or to look it up. I'm not too worried about that. It's more sort of certain conceptual things. So one thing would certainly have to do with the motivations. Like why? Why do we use a version control system rather than just doing version control by copying a file? Sorry? Space is a substantive issue. Particularly if you're going to tag a set of, or you want to essentially create a snapshot, I'll put it that way more generically. Create a snapshot of a system at a certain point. Sometimes it can be pretty big. Why would a system be big? I mean, after all, the source code of it isn't that huge. Well, there may be things like databases that have to accompany that. There may be data resources that need to go with it. There may be images and all those sort of things. And creating copies of it every time you want to have another sort of release or keep track of sort of what was the state then, that takes space. So space is one of the reasons. Why else have a version control system? And why not just make copies? Yes, it's easier to keep track of what was the change between X and Y. We modified this thing. But what really changed? Okay, so we have foo1.c and foo2.c. Great. But what really changed between them? That's often a point of great interest. What else is interesting when it comes to changes like that? These are all related to motivation. What other things what other things might we really want to know when it comes to changes besides what was changed? Who changed? Who, what, where, when, how, right? At least the W's. So who changed it? Who was responsible? We might want to go ask them a question about this thing, right? And we might not know when they changed it. That might be obvious in terms of the time associated with the file, but it is something that we might want to know. Where? Well, it's not as where in the file? Okay, they changed it. So those are motivations for it. Another thing is you want to be able to share it, right? Share this information easily. This sort of successfully modified versions of a file. And we don't necessarily want the element of the system that I'm working on to be the same as yours. You might want to branch it so we have parallel lines of development and easily remerge it, take into account that some of the files haven't changed. Some have changed between these two sort of lines, these two lineages of development. We might want to put them back together, right? These are common needs. So you split off, you have an important client, you split off a branch of the project to be dealing with their needs, and eventually that comes back and merges it. So motivation is one thing about subversion. Okay. What's another thing about subversion I consider really important? Well, it would be the whole copy, modify, merge approach. This notion that we have a repository, and the repository has a latest version, this head, of the repository. It's kind of the latest version across the repository. And we could do an SVN update and get that latest version, right? And modify it, and we can check it in, often through a commit. And if we're lucky, no one else is modified. If we're not lucky, we may have to do fix-up work. And you did that in lab 11, right? You did some fix-up between two components. So this whole process of sort of working asynchronously, I'm working at the same time you're working, and we're each modifying maybe the same file. Maybe we modify at different places in that file, but it all gets merged together seamlessly. Maybe we modify at the same place, and then we have to do fix-up. That's an important notion, okay? Or we can work on them at the same time. There's no locking. There's no, it's my file, and you can't touch it until I'm done. There's this sort of asynchronous feel to it. So that's important. Another important thing is actually this notion of an SVN commit. A commit is occurring in a way that's the semantics, the logic associated with the commit is very important to understand. What is notable about a commit? How is it different than just copying all of my files over to the server? How is it different? Sorry? Okay, there's a log, and that's actually really important. That's all that's logged. I'm not just writing atop of a bunch of other files. I'm not just adding a bunch of other files. There's some principled sort of log of that. But what else is different than just copying a bunch of files over there?
Keeps track of the old stuff.
Okay, the old stuff isn't wiped away. Good. So that is different. It's not just ground asunder underneath the weight of these new files. It's actually completely retained. It's no longer the head, maybe, but it's retained. So, but what else is unique about commit? Can view okay, that's true. They can view those traces. Why, that's not that different than copying files over. When is commit a lot different than copying files over? Under what conditions?
If somebody else is editing all this stuff, they want to copy your changes.
Good. So you want to just sort of write over willy-nilly someone else's changes, you'd be alerted to that there's a conflict, and you have a chance to kind of resolve that without unintentionally stomping on what they've done, clobbering it, as we say. So that's a difference. But what other, there's something that's very important. Under what conditions would copying files say, I'm going to copy all these .c files over to that server? How would that be different than commit? There's an important difference, and it occurs under a certain condition. And I've inveighed upon you, I've exhorted you folks, and I exhort you even now, as part of this class, to bear in mind not just the typical case, but the what case. Well spoken, young man. So do you care to expand on that? So what's an atypical case? One we heard where someone else has modified it. What else might be atypical? If something bad happens, right? Something bad happens to the way the network disconnects halfway through. There's a disk error. There's a problem updating files. It runs out of space. Again, you may think that these can be brushed under the rug. They can't be brushed. If you brush these things under the rug with a lot of computer systems, you're digging yourself a grave in terms of the functionality of your system in its real life use. Particularly in distributed systems where we've got things in different machines, if you assume that things are updated instantly and they're updated completely and errors don't occur, that's like the kiss of death in terms of the potential for real life use of your system. Sun Microsystems, folks there wrote a paper about that at one point, and they say essentially things that make you think that all these nice properties hold automatically, you're just cruising for bruising. You're going to be ending up with really buggy software that crashes a lot. So SVN commit has a very special property, ladies and gentlemen, when errors occur. What is that property? Nothing happens. In other words, ladies and gentlemen, it is atomic. It's an atomic protocol. It either occurs completely or it doesn't occur at all. As far as someone else is concerned, ladies and gentlemen, man, I should have made that point in class. As far as someone else is concerned, it either has been done or it's not done at all. So if there are two people updating on a given set of files, maybe even some of their files are being updated. Either A will go entirely before B or B will go entirely before A as far as the updates are concerned. Actually, I did make some muttering about that. I made an utterance about that that may have gone unnoticed. But the point is, two people could be updated. If you don't believe this, you know, there are projects out there where thousands of developers, tasks of thousands of cubicles, and they may be updating two files. Think about it. It's just before, you know, a talk, or just before a product announcement, or some other common deadline, and so they all want to get their things in just before that. It's just before 5 o'clock, and they got to go pick up the kids from daycare, whatever. They want to get their stuff in, and they have some common deadlines, so there's correlations. You know, one may check things in at the same time the other one is. And the point is, these things are not mixed together willy-nilly. They're not, you know, the foo.c is updated by A and bar.c is updated by B, and overwrites each other's files. Okay, no, either A's updates will all occur before B's, before all of B's, or B's will occur before all of A. It's sort of got this nice property. It's occurring all at once. It's occurring entirely or not at all. And one person doesn't see the other results of each other's changes halfway through. And if there's an error, even if there's this corruption, it won't end up in a state that's sort of half-baked, that's corrupted by half a file being written or something like that. It's either fully or not all. Clean, clear, and it really lowers the risk that you'll get some weird conditions that require very expensive cleanup. So this commit is atomic, and if you have in your commit yielded a state which has a conflict, you don't have to worry that, oh, all my other, you know, that maybe file, this is really important, folks. Oh man, is this important. So maybe you were updating foo.c, maybe you were updating bar.c, and maybe you're updating baz.c. I know you surprised at my unexpected enthusiasm. But suppose you're updating foo.c, bar.c, and baz.c. Maybe you've made changes to all of these that are consistent in some way, right? You've modified square root to take two arguments in baz.c, and now foo.c and bar.c call square root, right? Okay? They call that new version of square root. Now suppose you're checking in each of these, and you'll notice they're handily written in a alphabetical order, which is not a surprise given their canonical ordering. So foo.c, oh, excuse me, they're not. Oh man. Well, a beautiful theory killed by an ugly fact. Huxley said it first. So foo.c and bar.c are updated perhaps fine, and then baz.c has a conflict. Maybe someone else has modified square root, right? if it gets to this point and discovers baz.c as a conflict, because it's atomic, have these guys been updated, foo.c and bar.c? No, there's no changes. That's important, because imagine if there were changes, ladies and gentlemen. Imagine, ladies and gentlemen, that those in fact had been changed, foo.c and bar.c, before the problem occurred in baz.c. In that case, you would have to scramble, right? Because you'd say, oh man, I've got to roll back foo.c and bar.c so that people can't see the latest versions of these until I can fix up baz.c. In other words, these ones would have been, in a way, corrupted. Foo.c and bar.c, the updates would have corrupted the current state of the head, the current state of the subversion repository in such a way that people couldn't compile it anymore, because they don't have the new version of baz.c, but they've got foo.c and bar.c that depend on that new version. So it's very important that either these all get uploaded at once, this whole consistent set of files that work together in a consistent way, that are in sync with each other, or none of them get updated. Do people appreciate that? Okay, it's very important that you not sort of get halfway through. And if it didn't do that, you'd be fixing up these earlier files, saying, oh man, I got to roll those other files back. Which of them have been updated? Let me undo that. Okay, so atomicity is another property of subversion that is very important. What's another property of subversion that I would really want students to know about? Well, I want them to know the basic commands associated with subversion. How do you create, ladies and gentlemen, a SVN repository? Through what command? Exactly. It's not SVN by itself, it's SVN admin, right? Okay, so you create a repository. It can be created on your file system, or it can be created on a machine that you access remotely subsequently. And then there's a set of commands that I expect you to know. Ladies and gentlemen, speak as if in a Greek chorus of common, let us praise now, famous SVN commands. Okay, great. These are great. A Greek chorus, as a Greek chorus that doesn't break historical records, but it does. You did communicate many of the important ones. So, update, commit, log, diff, status, SVN, resolve is another one. Where is resolve used? When there's a conflict and you feel that you've gotten beyond that, you can flip the conflict bit, tell it, hey, this is no longer in conflict, right? Those are all common ones. SVN add is another very important one, to add a new file to a repository. And ladies and gentlemen, it's very important you realize that those things are not visible by default. If you're performing them in your working directory, they are not visible until you perform what? Okay, that's true. The checkout has to occur before it becomes a working directory. So all that is true. And I don't dispute that. But if you've already got a full working directory, you did an SVN checkout, very important command. Great. Okay, you do an SVN update to get the latest version, the head version, or to get it from a past version. But then your SVN add, for example, the results of that won't be made visible to until SVN commit is done. This is what allows that all to happen at once. The files you added, the things you changed in those files, right? Those things, the results of your resolve, those things will not be visible until you do your SVN commit. And then they're visible all at once. Your whole set of consistent changes. Because presumably, ladies and gentlemen, you've modified your code base in a consistent way, in a way that it works. And it makes sense that when you update the repository, you update it with another whole version that's changed, but works. It works self-consistent, right? Okay, so that's another nice property about subversion. And understanding these commands and the fact that they work with svn commit at an important level is very important. I will expect you to know something about a convention that we undertake with subversion. A convention having to do with the way we structure repositories. Can you speak to me, ladies and gentlemen, as if in a Greek chorus, of ways that we structure a repository? What are three common branches at the top of, or three common, a tripartite division, if I can appeal to my Latin again. Or is it Greek? So a tripartite division, a trichotomous division. Between, there's a triumvirate. Yeah, okay, so all Gaul is divided into three parts. So what are these three components? Okay, good. Yes. So there's the trunk, and then there's the branches, right? And then there's the tags, right? Okay. So ladies and gentlemen, speak to me as if in a Greek chorus. We have to do it 3 times at least. About the functions of each of these. So what do tags do? What do they give you? Yeah, they're snapshots. They're snapshots. They're snapshots of typically of the trunk at well-defined points. Now, do those take up a lot of space?
No.
Essentially, no space. Why?
Because you should be moving very 5 seconds. You should have to every main change.
Okay, that is true, but even if you were to do them every 5 seconds, that would accumulate. But it's true after you've made your change. But why aren't they, even so, even if you were to do them daily or something, why wouldn't that be a big problem? Okay, good. Copying, and this is an important factoid about subversion, copying is cheap. What I mean by that is, all they do is refer to. They're like links to certain, yeah, it's a pointer. Yeah. We won't get into whether it's represented 32 or 64 bits and so on, but it's a pointer. Yeah, it's a handle to something. It's a reference to something else, right? So these are snapshots, and they might label version 1, version 1.5, version 2 of your product. Maybe this is the version for, Goldman Sachs or something like that. Goldman Sachs first release or what have you. Bank of Canada. These would be in different snapshots. And so each of these would be a picture of the system, like that you use to deliver to a client or that you gave to customers, version 1 or something you released maybe. Or maybe it's a version of your website that you made visible at a certain date, right? Okay, so that might be a certain tagged version. What's in the trunk? Yeah, it's the main sort of where most people are sort of working, or where the most development is going on. It's kind of the main line of development. The main thrust of development occurs with respect to the trunk. And then what are branches? How do they differ from a tag?
There are changes going on.
Yeah, there's ongoing changes. So the tags, this is really important, folks. The tags are snapshots, and there's no, by convention, there's no ongoing, almost by definition, there's no ongoing work going on with the tags. By contrast, in branches, there's ongoing threads in development. So these may be things you're working on for the next version of this, for example. Maybe you're maintaining the current version of the system, doing bug fixes, improving this bit of functionality, what have you. Whereas in the branches, ladies and gentlemen, you may be doing ongoing development for a new architecture of your system. Maybe it's, you're doing ongoing development for some particular customer, and you've got an original split. At one point it's split off from the trunk. Maybe we should draw it this way. At some point or another, this split off from the trunk. Maybe this one originated later, along in the trunk. This one originated later. But you've got this sort of work going on. Now the most recent version of the trunk is called well, it's the head. It's the most recent snapshot across the whole repository. This is worth noting. The head is really sort of the current state, the latest current state of the repository. Someone just checked things in. Chronologically, someone just did the latest changes that someone did. They yielded a number that sort of labels the state as it is right now across the entire repository, right? And that's associated with the head, but certainly trunk is part of that. And these branches are sort of splits there. And what eventually happens with branches often? Eventually they merge with the trunk. And the version history really aids with that because we know, oh, the certain file, you know, this certain, this is some extra one there. So this certain, there may be a file here, which is still the same file as was up here. And, you know, over here, maybe it's been updated since, and when we merge it together, it just, you know, prefers the changes that came from this side or what have you. So it actually makes use of, when we remerge, makes critical use of this shared ancestry. The fact that these things originated up here, and it knows there was sort of this common stuff in place there, and then there were a bunch of changes here and changes here. And often there's some sort of imports of changes along the way as we bring in certain files. So big picture, I would expect people to have some idea of sort of how subversion conventions work in terms of the tripartite division into tags, trunk, and branches. Okay. So any other really big things? Well, who is it? What command is it, folks? That tells you when there's been a conflict. Fdn commit tells you that there's been. What's the one that gives you the files, though? That's update. That's update. That will actually let you say which file do you prefer. Do you want to postpone it, and do you want to resolve them yourself, right? Do you want to do a P, or do you want to do a just prefer upfront my change or their changes or whatever? Yeah. Okay.
Sometimes it's a checkout trunk, I get a folder called trunk and have trunk inside it, and then SDN within there too.
Right.
Sometimes I check the trunk, I get the files from trunk, but not the folder trunk, and then SDN is there. And I don't know which way to type the commands that gives me a folder with the direct contents and then SDN on the side. But
In other words, you don't want a subfolder.
I don't want to subfolder, I don't want to make the current directory or the current directory become trunk. I don't want the thinking trunk to just appear everywhere.
Because I know recently a detail that trunk take branch. I think the first one we did was remove the trunk take branch. That might be up.
Trunk. Sorry. So trunk takes somehow you had the.
He's in tags, not takes.
Oh. Okay.
He's thinking of maybe the absence of branches subdirectory makes a difference.
No, like, we had a project for called detail repository. I just did branch trunk heading to branch.
Right.
Do a project folder like this now, and not like that.
That is possible. I would. So you're looking to have one folder under the current directory with an appropriate name and the .svn folder inside of that, and all the files inside of it. Not inside.
Basically, if I import
I see.
truck, I want truck to appear with both of these files inside,
Yeah.
and then not have SVN be inside of it, then I can only do check that and do updates and stuff when in the folder.
Correct. Correct. Yeah, I'd have to get back to you on that. I mean, I have some guesses I could offer, but I can't do so reliably right now. So I'd have to play with the syntax a bit. Normally, the case that I've done it with is you get a subfolder and the .svn is in there, but I understand why you might want this higher level folder as well, because you want to be able to do svn adds from that or what have you. SVN maker. Precisely. But and of course, one way to deal with that is to make those things ahead of time before you do the SVN import command, right? To create the tags, branches, and trunk directory, then do an SVN import of that, and then you can output. You can grab the trunk part of it, for example, later, but you've already got the yeah. No, I appreciate that. Yeah. 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 Okay. I understand what you're saying. I'd have to play with that. I can't answer that off the top of my head. There should be a way to do that. I just don't know exactly right now what arguments you'd give to it. I suspect probably half an hour of playing would show it. Just systematic examination of that. It's a good question and one I can't answer right now. So, other questions?
In one of your example files for SVN,
Yes.
you use push and pop commands.
Yes.
Yes. Stack
Yes, that's right.
system that can
Yes.
visualize looking at the sort of tags, trunk and branches tree.
That's right.
How does that
Okay, so certain of the shells, this is a good question. So in those files, we have we make use of some tricks for simplifying use of subversion. One of the tricks has to do, for example, with defining a shell variable. Right? So you have sdnhome or something like that, and you set that equal to some path, and then you can use sdnhome in certain places rather than having to manually type in file // So that's one thing. You'll see that in some of those files. In the example I sent last night, I didn't include that just to make it as transparent as possible. But that's one thing. Another thing that we have is we use push and popter to sort of simplify some things. And the relevant commands here are push D and pop D. The idea here is that certain shells support this notion of a stack of present working directories or current working directories. And the idea here is that when you're at a certain location, you may do push D, and maybe you move around. You do CD to this other place, etc. And at a later point, you may do pop D, and you're suddenly back to where you.
Oh, so it's like a back button, right?
Yes. Yeah, it's like a back button in the browser.
Choose with the members.
Yeah.
It's a column now, so 35
Exactly. Yeah. So it would be as if it's good and very relevant point. So it's like a back button where you can select what gets remembered by that back button. So you say push D, and then later, 100 commands later, you say pop D, boom, back to where you were. And that's sometimes quite useful because you're in the middle of exploring something temporarily, but you really just want to get back to where you were later with confidence. So it's kind of like you're putting in a placeholder and say, bring me back home, boom. But it's more extensible than that because there's a whole stack of these things. So you can do it several times. You can do it recursively, really, and get back to one and then get back to another. What's that?
For your events, that'll be able to protect the people going back.
No, a more evocative analogy than I had come up with, but one that's nice. That's right. So it'll bring you back very easily. In this case, it's a whole stack of heels, right? It's like a stack of shoes. Cinderella's stack of shoes. Okay, so that's a good question. What other questions can we come up with? Anything, I think. What other topic?
We're going to be using Makefiles for the recursive.
Yes.
So is that something that we're going to make sure in some of this?
Yes. Yes. Makefiles. What things do I consider important in Makefiles? Well, I can rattle off a bunch. So the most basic thing I expect you to know about Makefiles is their central structure. Okay. I expect you to know that there are targets, there are dependencies, and there are actions. A target might be a file. Could be a object file. It could be a entire program. It could be a conceptual action like clean or like all or tests. That's not per se one particular file or artifact, but it rather reflects a deliverable of some sort or action that needs to be, action is not the right word, a goal that needs to be achieved. Okay? Okay. So there's targets. There are dependencies of those targets. Something that, for that target to be achieved, it needs certain things to be in place. Mm-hmm. And what's really important with this, ladies and gentlemen, what's A1 important is that in fact, maybe I should go and take a look at some Makefiles here. Let's see. So this one actually has quite a few examples here. So the Makefiles down here are quite nice. So take a look at this. This is in its most sort of basic form. The Makefiles have these dependencies, these targets, these dependencies, and these actions. Now, what's really important to recognize is that this target here that depends on these dependencies, what this is really saying is, in this case, this is actually a file, right? And it's saying, okay, to produce this file, either this file exists and it's later than all these dependencies, or we need to get the latest version of these dependencies and then make this target, right? So under what conditions, this is A1 important, this is like uber testable. So under what conditions will this action be triggered? Give me two separate conditions under which this action will be triggered.
If one of those dependencies is newer
Good.
than Queens,
Good. So that's a whole class. Then that's a whole class of possibilities. It could be solver.o, state.o, queens.o. If those are newer than queens, this action will be triggered, right? Give me another situation which this action will be triggered.
if one of their dependencies is newer than them, so it says it'll get to solver.o, it will check the rule for solver.o, and if solver.h is newer than
Great.
solver.o, it will run that and then run queen.
Good. Good. So it may be newer than Queens, but if it's outdated in the sense that one of its dependencies is more recent, then it will be updated, and then it will be more recent than Queens, right? So that's good. And I'd say by extension, the first of them, if Queens doesn't even exist, this will be run, right? Are people comfortable with those cases? It's very important to recognize that this is a recursive procedure. In other words, so this point that was just emphasized, that to find out if Queens is up to date, we need to examine if the things it depends on are up to date, right? And if not, make them up to date. To put it better, to use the Queen's English, not to do the Queen's English, barbaric rendition. If Queens is not up to date, then we're going to make Queens up to date, we first need to do any changes to make these dependencies up to date, and that goes on recursively to their dependencies, and then we need, if required, if Queens is either doesn't exist or is older than any of these dependencies, we need to make Queens, and so there's a recursive sort of character to the whole process. That is perhaps the most important thing about Makefiles right there. Okay? That tripartite, once again, division, the target, dependencies, actions, and the recursive nature of the actions that take place, that are required. Okay, so that's the most important things about Makefiles, but that's not all I expected. In fact, I expect several other things. So what other nice features? Well, let me make sure we have a sanity check here. Makefiles. When might you use Makefiles?
If you're making more than one product, and that's how big project, it's lots of functions in the big file, then you have all
Good.
these C++
Good. Does it have to be G++? Does it have to be?
whatever language whatever you compile.
Indeed. So could these be useful with C? You bet. Could it be useful with Java? Absolutely. Could it be useful even if you're not doing programming in a strict sense, but it's in a sort of with a common language, but instead you're doing shell scripts, or you're doing sed scripts, or you are using Unix commands to combine files together, produce other files. Could this still be useful? It could be, yes. I mean, Makefiles are this whole notion of keeping things up to date and having dependencies and actions if they're out of date. That's a pretty fundamental notion, actually. There's just a lot of areas of human activity which fall through that. Workflow, you gotta update this paperwork if you have new paperwork that comes in on these other things. These are pretty fundamental notions. Okay, so that's good. What other, I guess just in terms of syntax here, sort of the crude phrasing of this, what's one fact about the structure of this file? What thing would you warn someone about if I gave them a Makefile for the first time? They wanted to build it up.
Don't make files that say names and make files.
Okay, that's good. And we'll get to that in a minute. Excellent. What other things?
See what it's going to run for you.
Okay, so say that again.
Like check the contents of the file.
Yes, right. Yeah, so checking the contents so that you can make sure that it's going to do something meaningful and not screw things up in your system, or not overwrite something user bin or something like that. So that's good. What about this indenting? Tab. Single tab. Makefiles are extremely picky about this. And you could look at a Makefile for hours, me wondering why it doesn't work, and it's because there's spaces screwing it up. It's very picky for that.
Could you write a script to validate?
Yes, you could. To make sure that it adheres to proper grammatical structure. Yes, you could. In fact, you could write scripts that would clean up a Makefile using Z, right? Would replace all spaces by tab, or what have you. Yeah, space at the beginning of lines by tab. That would be quite straightforward. In fact, it's so straightforward that not that can even deal. Well, fine.
Sorry.
Maybe next year's lab 11 or something like that. So these are some basic things about Makefiles. But what other things? And so you have these comments up there. What other things do we have as we add things to Makefiles, though? We actually covered a number of different layers of sophistication Makefiles. This is the most basic, and this is the most important. Well, let me ask this. So, again, another standard shape. We want to add another action here. How do we do it for this state.o? We want to make it use a sed script to actually edit something in state.cc, replace one name by another or something. Exactly. You could have several lines under here. It's limited like that. So that's good. Okay, but what things could we add to a Makefile to make it that are more sophisticated constructs that we covered in class, or that you saw in your examples? Okay, variables is an important one. What's another one? Yes, exactly. So phony declarations. So, do people want to speak with me about each of those? Okay. So this is an indication that we want to make everything associated with this project. We want to make the Queen's program, but we also want to make all tests associated with this program. And the tests here include two dependencies. There are two targets in turn, test state and test solver, which are different executables, one for testing the state, one for testing the solver, test state and test solver. So this is a target, it's a goal that's associated with building all things associated with the project. And we will often have a test clean, although it's not, a make clean. So make all is very, very common by convention to have. And often you'll have a make clean. This is, again, sort of time-honored convention. You have make clean, which cleans a bunch of stuff up. Cleans up .o files and executables. Why would you have make clean? Why might you need that? Why might you want that?
It's an easy way to move all the junk and garbage that you might not need.
Good. Junk and garbage you might not need. And sometimes, ladies and gentlemen, that junk and garbage causes you to trip up. Sometimes it causes you to actually end up in a situation where you actually get results out that are screwy. So if you're using incremental linking, if you have a situation where something has been updated, the time associated with a given file perhaps has been set incorrectly or what have you. Doing a make clean to clean everything up, build from scratch is often really useful. For example, maybe you've suddenly gotten .o files copied into your system from other sources, from other people's machines. You don't know what version of the code they were from, but they're more recent than your .cc, but you don't know if they're really as recent as the CC file in terms of the real sort of version of the version of the trunk they're associated with. Maybe they made them on their machine, but they had an older version of the files on which they were based. And so if you have .o files that have been updated from someone else's machine, you do make clean, you clear that all out, and then you make screwy results. Sometimes something has gone awry with the making, you make clean, and you build it from scratch, and you're fine. Maybe you have changed something in the compiler options that you want to use. Like this -03. Do people know what that's for? Optimizations, right. So that's a really powerful level of optimization. Sometimes it actually can do things that are a bit risky. It may assume 2 pointers don't point to the same thing. When you write to one, of course, you're not going to change the value read by the other, but sometimes you want to change those things. Or maybe you want to put in -G for all your commands. What would happen if I put in -G? Why would I do that? For like, I want to insert debugging information. Ladies and gentlemen, if I went and I put -G here, and I said, so suppose I did a make all. I made everything in this project, and then I went through and I put in -G for all of these different options. Why would I, and suppose I did a make all again, what would happen? Nothing. Exactly nothing would happen. Because it doesn't know that the make file is outdated. So what could I do? I could do a make. You know, young man, it is, and that's a fine idea. I've actually never seen that in Makefiles, but it's a good idea. Oh well, okay. Except that it's a blunt instrument. What do I mean by a blunt instrument? Well, this is true. It's inexact in the sense that if I said this depends on Makefile, right? That you have to update queens every time the Makefile's been updated. Maybe I've just gone and I've changed and a test solver also depended on the Makefile. State.o depended on the Makefile.
Yeah, then it would update.
It would update everything.
Yeah.
Right? So really what you can do is you can update the Makefile, put in -G across all, and then do a make. You do a make clean. Now make -W can be used to force it into thinking that something has been updated, but make clean would be clear away all the code that's, the outputs from compiles, and then do a make all. Right? Make clean, make all. After you've updated the make file with -G across all options. Because you gotta reproduce all of these files. Does that make sense? Yeah.
If you do a make clean all, would it do clean them all?
Never tried it. I would imagine it might, but I can't say for sure. I would hope it doesn't do a make all and clean.
That would be a make clean if you wanted to.
Well, assuming it had already been built, yeah. Doesn't hurt to try. Here we have a way of cleaning up, and it reflects the fact that sometimes you change things in ways that it's not smart enough to know about the dependencies. Okay, so that's good. Let's go to this next level of Makefile. Here's .phony. Why do we put in .phony? Yeah. Yeah. So the deal is, if there was a file called all in that previous Makefile, it would have tricked it. Oh, all is more recent than Queen, so we don't have to make, when we say make all, it wouldn't make anything, right? Or what have you. If there was a file called all, it might not think anything has to be done. This is basically telling us, hey, look, these all tests and clean, those are goals. Don't check for a file called that. Don't see if the file is out of date. If you're told to make all, you don't need to go looking for a file. You can just see if queens and tests are up to date. Okay? That's all you have to do. You don't have to look for a separate file. And that can save a bit of time. It can save unnecessary access to the disk, but more recently, it just prevents having to worry about files with these sort of names, or a file called clean, a file called tests, or what have you, or a directory called tests. Okay, so down here are actually more commands or more goals than they are file. Some of them, like Queens, are still a file, right? It's produced. Test is not. Test just says, okay, produce an executable so that you can run called test state and another one called test solver. Yeah. So it's test is not itself a file, but test state is and test solver. And test is here, but not there. Okay, does that make sense? So the final component that we have here, and by the way, these are on your on the Moodle page. I'm pretty sure I had uploaded them. The final component is associated with this. Actually, sorry, it's not the final one. I wanted to do this one first. This is I'm quite comfortable with. The next one I exhibit discomfort. So here what we've introduced is macros of sorts. These are variables. So we group together definitions of things that are logically a unit or logically linked. We've created a means of abstraction, of sort of characterizing a set of things that are logically linked, like all object files associated with clones. State.o, solver.o, queens.o. Why might we do that? So we use this here, and then we put it here. Speak use as to several reasons why we might want to define a variable like that. Great. Because there are several places that actually need it here, right? So here's one place, here's another place. Rather than, having to put it in each of these places, it depends on it, and sometimes forgetting, right? Maybe a phone call comes in after you've updated this one, and you haven't gotten to this one. Talking on the phone. By the time you put down the phone, you've forgotten that you're in the middle. You still have to update this. You walk away, and there's a bug in your file. In other words, these things are logically linked. They're the same thing. Here we are linking together a set of the object files to produce an executable. Here we're saying that executable depends on those object files. So there are a set of things, the object files associated with queens. They're it's a unity, right? Similarly for tests here. And then we have a CXX flags. Why do we link those? Well, we're using those multiple places, right? We're using them to compile the tests, to be sure. We're using them to compile each of these files associated with the Queens objects. So here, and then we can also do this thing where we delete the Queens object, for example, down and make clean. So it makes sense to have this kind of means of abstraction, a way of sort of grouping these things which are logically used in several different places. They're really the same thing referred to in several places, and by having a way of referring to it with a name, we can define it once, use it many times, right?
Could you string them together? Say you edited the program, and you know that you required object files, say Rooks_orange, and you knew that it would depend on everything that Queens did and one mar file.
Yeah.
Could you set Rooks_object equals Queens?
Exactly.
Object?
Exactly. Yeah, so you can define one recursively versus the other. So, yeah. Good. And you'll notice this sort of definition with the dollar sign. Okay, so that's a flexible way of extending this, and one that can genuinely clean up your file, keep fewer things to worry about. The final thing is where an ugly truth, which has positive sides and negative sides, is revealed. So it's kind of like a chimera. It has the head of one animal and the body of another. The head of beauty and the body of a beast. So here, ladies and gentlemen, we can actually define the same Makefile with great conciseness, or as my colleagues are wont to say, great concision. And so here we have this same file compressed down. Notice state.o is just defined in terms of these. This is the target, state.o. State.cc and state.h are simply the files in which depend. Solver.o exhibits a similar sort of pristine beauty to it. TestSolver.o, a similar beauty to it. There's great succinctness. It is terse, to the point, and captures the essentials. And here, so those are the definitions of the .o files below. Up here we have the definition of the targets, and here's the Queen's target, test state, test solver. So that's all very good, and we still have to clean. So how is this all working? Yeah, make knows about C, and there, ladies and gentlemen, lies the body of the beast, because we have to define for it certain built-in macros or built-in variables like CC it knows about, CXX it knows about, CPP flags it knows about, C flags it knows about, CXX flags it knows about. So this is C++, the X is like a plus turned on, turned 45 degrees. Yeah, the body of the beast. It struts around with its it's rearing. At least its tail is beautiful. With the concision allowed. So here it knows about how C works and how C compilers work. It just needs to be told what the C compilers are. So here the CC compiler is told to be used as the same as the CXX compiler. This CXX is defined, I believe, as an environment or shell variable externally. And so here, basically, it says, oh, there's a .c file here, and we want to produce a .o. I use my C++ compiler, the CXX compiler. It says here, oh, you're producing something based on object files. I'm going to use the loader flags as part of that in the CXX compiler with that. Notice we can tell it these C++ flags, but it actually tells the C++ compiler, hey, we're compiling to produce a .o file, so use -c, right? So here in all its primal glory, the griffin, the chimera, is this sort of latest evolution of Makefiles. We have .phony, we have these variables, but we also are appealing to the fact that Make knows about C++. So it knows about C++. I have great mixed feelings about this because I don't like privileging C and C++, but the fact is it's so deeply rooted in Unix history that it's hard to excise. And secondly, you can use Make just fine with other languages. It's just it doesn't provide this built-in support. For C and C++, for better or for worse, for Chimera or Ribbon, it does provide built-in support for these. So this is the final bit of the Makefile that you should be aware of, that it does provide built-in support for C and C++. Do I expect you to know the syntax? No, but I do expect you to know that, yeah.
Just out of curiosity, are there other languages that are supersets of other languages?
Yes, there was D, which is a superset of C, but D did not survive. There's certain so there's a history of languages that have been sort of aborted or truncated. So I was involved in an early C#, and that one was at one point sort of called off in favor of waiting a few years for the final one, which came out. There, it's a good. I mean, there's a profusion of languages based on Lisp, which is a language of beauty with no body at least. And that one's enjoyed quite a bit of sort of flourishing, and in fact a huge profusion. C has sort of spawned a set of many languages, like Objective-C, for example. Are you familiar with Objective-C? Objective-C, yeah. That's sort of a contender for C++, but Objective-C is used a lot in the Mac world, and so that's also based on C. But other languages, yeah, there's often there's a little profusion bursts of languages which occur, but C++ and Objective-C and C#, and then the Java family, they all inherited so much from sort of C's basic, some of its basic features that they're particularly tied in. And I particularly note C++ and Objective-C is tied into C. So there are other cases of sort of little explosions of similarity based on a common ancestor. Question though.
Yeah, for assignment you say we should test the Makefile and then
Right. Testing the Makefile here would involve making sure that if you were to touch a file, for example, touch a CC file, that it recompiles the appropriate targets. So in this case, one thing it might recompile is the main executable. Another thing it might recompile would be the text, right? So you want to make sure, similarly, when you touch a .h file, that it similarly updates the appropriate targets. Yeah. That would be a good way to test it. And once again, it could be done in an automated type of fashion if you wanted to do something like that. Okay. Other questions about Makefiles? Okay. So other topics. Who